Tom's, what's your name? I forget your name. Julio. Tom's IT Pro Julio. Tom is in the house. I wanted to call you Tom, but that's not right. Welcome, guys. Hey, everyone. I'm Rick Vanover. I'm with Veeam, and we're going to talk about some pretty cool stuff here today. Thanks for coming out, everyone. I know a couple people asked for it on Twitter. Hopefully they find the place. Let's go ahead and get started. I want to talk about, the way you think about storage for backups. A lot of times people don't put the same amount of effort on backup storage as they do running VMs. And when it comes to running a VM, I mean, there's a lot of decisions that you'll make, right? You want your VMs to run well. You want performance and availability characteristics of your VMs, but you may not do the same thing for your backups. And I kind of like to level set a little bit with kind of like when you buy a car. You get the mileage sticker on your car, and I like to kind of say that your mileage will vary. That's going to happen with storage when you run VMs, but it also happens when you run backups also. So I want to kind of level set that there's no, perfect way to design stuff, and by the end of this, hopefully, you guys kind of get a sense for a lot of the other options that we have. So let's take a look at the first thing, right? When we talk about the way we back up with Veeam, we have a number of different components. And the funny thing is that they all have different requirements, okay? And when I say requirements, it's one thing to just throw it in, but it's another thing to actually make sure that the knobs and dials are set up well so that our backup and such performs to our expectation. So I'll kind of start out with the first thing, the console, right? That's where you install Veeam, right? That just works for many installations, smaller environments. That's pretty easy to do. But the reality is that's really just part of the architecture. When you install the console, all the other pieces come in, but then things like a proxy, a built-in WAN accelerator, a repository, all these other components come in to really dial up our protection scheme. And I'll talk about how they work and where they sit here in a moment. But basically, and the last of those is honestly the most important, and that's what I call the repository. So when you talk about backups, they always, especially in Veeam talk, need to go to a disk resource. And so when we talk about the disk resource options in Veeam, that's going to be a repository. So I like to pretty much say it's anything that Windows can get to, which is very flexible in my, what I do. I'm really comfortable deploying storage on Windows. And from there, that can include local disks, SAN volumes, CIFS and SMB shares, as well as iSCSI LUNs, Fibre Channel, direct attach, USB storage. Pretty versatile to say that anything that Windows can get to is where we can put a Veeam backup. And then lastly, anything via Linux, right? If you want to go to an NFS mount or if you have a very large Linux system, those are welcome candidates as well to hold Veeam backups. So I like to start with just kind of getting those components out there because those have their own requirements. The first of which is the console, right? There's like a lot of times I get feedback on Twitter, hey, this isn't working as I'd expect. I shouldn't say a lot of times, but occasionally I get that feedback. And people might have just thrown it in there, right? Installed Veeam, and they're trying to back up 500 VMs, and they haven't scaled the solution out at all. Every one of these components have their own requirements. Everything from RAM and proper OS support, disk cache resources, as well as concurrency. And I want to zero in on one thing right here. And actually, I didn't even know this till 2 weeks ago when I was prepping this up. And when we talk about the storage for our backups, we actually need 2 gigs of RAM per concurrent ingress job. And I didn't think about that at first. We can do it with less, but it's not going to perform as optimally. And what I mean by that is, we read through the APIs, through VMware, it's a great framework that it provides us, right? The vSphere APIs for data protection. It's an incredible framework to interact with. We read those, and then we do our other things like that VMware gives us, like change block tracking, and we even can communicate through certain modes. But when we start moving the data, that's a lot to be moved. So we want to make sure that there's enough capacity from a memory standpoint in particular for our repository. And 2 gigs per concurrent job was kind of the little shocker, right? And what I mean by that is if I only provision 4 gig of RAM for a Windows server to hold my disks for backups, that means it can optimally receive 2 jobs. So if I'm really concerned about speed, then I want to keep this in mind. So these things add up. So give those some thoughts. And really, I took these all out of the release notes, right? Hey, Mike. Hey, Tony. Welcome, guys. Thanks for coming by. But basically, the release notes are really where you can get all this good Veeam stuff in terms of the requirements. So never really forget all of that. So the first design I want to talk about is a really small virtual environment. So when it comes to small environments, I think that they still have an opportunity to really cash in on all the benefits. So the first of which is really virtualize everything, right? Have the Veeam console, all the individual VMs, and the repository, if you'd like, virtualized. Now the catch here is you want to make sure that there's enough separation so that if you really lost your entire virtual environment, including the storage, how could you still deliver a restore? And that's where I like to say that having some sort of external storage resource would be a really good idea. And the best part is it doesn't even have to be expensive. It can be a NAS resource, iSCSI storage. There's a lot of options in these unified storage options that are very inexpensive. In fact, if you had to make a decision, I'd probably nudge you towards iSCSI and have the Veeam proxy, Veeam console latch onto that LUN directly so that it could actually own that disk resource and effectively do a direct-to-target type of data mover. Pretty clean and simple design, but from there it gets a little bit more complicated. And I'll take an example of 200 VMs with like NFS, for example. Now, NFS doesn't let me do all of those vSphere APIs for data protection. Like I can't do the direct SAN mode, right? Which is my favorite data mover. But you know, back when we talk about how we deploy virtual machine storage for the primary VM, we want to think about, well, do I want NFS? Do I want SAN? And there's a lot of reasons why you might make a storage decision, and NFS can be one of those decisions. So what I've done here is kind of interesting, and I've put the proxies as actual virtual machines. In this mode, they can actually use virtual appliance hot add, which is actually really good for the changed block data information that comes from the VMs. When the VMs go in through hot add as a proxy with a virtual machine, they actually share the I/O stack with the virtual machine that they're backing up, and they actually can move data very fast. Now, if you have 10 gigabit Ethernet, you can actually do pretty good with 10 gig Ethernet in network mode. But for NFS, the best kind of single option would be the virtual appliance hot add. Now, I have an option here to have this virtual backup repository on a physical server with direct attached storage. Now, this is VMworld. I don't really think everybody's pro on virtualizing, omitting things from their virtual architecture. But one little plus for this architecture here is actually if there's any high I/O from the proxies to do things on their backup targets, you can actually take all of that I/O and CPU burden outside of your cluster. Now you can flip that around and make that all virtual, just like this. It's the same source virtual infrastructure. And if you have a dedicated virtual infrastructure with maybe a VMDK assigned directly to a proxy, or even an iSCSI LUN or a dedicated NFS target, you can actually virtualize the whole thing if you'd like. But the important thing to note is to always have separation. And so on these designs, I have certain things green, certain things blue. The green stuff is the Veeam components, proxy, jobs, repositories, etc. It's important to note that they're separate from the production VMware environment so that in case there's a catastrophic VMware environment, everything from your Veeam configuration to your actual backups are fully removed from what could potentially fail. Now, you can also combine the proxy and the repository. And I mentioned this direct-to-target phenomena. That's a great way of doing that. Now, for the iSCSI fans in the world here, this is where my favorite data mover comes in, and that's direct SAN access. So the vSphere APIs for data protection also give us a way to communicate directly to the storage, which is the most efficient data mover if you're using the VADP toolset. So in this design here, I can actually make the repository a virtual machine and even give an iSCSI LUN as my backup target and assign it directly to the proxy. So depending on how I slice up my storage network, I can actually even make the entire infrastructure virtual and then just have dedicated LUNs on the iSCSI storage. ideally fully separated, in case the primary full SAN, not just the one tray or not just this controller, but the whole storage network. I can put in as much separation as I'd like, including things like the configuration backup, which that's an important thing also because you can quickly rebuild your Veeam config with that built-in new feature. That's good stuff. And then number 4 is when Fibre Channel comes into play. And again, this is the same 200 VMs, but what I've done here is I've actually put in a physical proxy. Now, I did mention that the vSphere APIs for data protection are an incredible framework, but you can't always double dip. And one example of that is I can't use the vSphere APIs for data protection's direct SAN mode with VM Direct Path HBA, which is a way to kind of virtually give a Fibre Channel interface to a virtual machine. So I can't really do both in a properly supported configuration. So what I've done here is I've given 2 proxies with an HBA and the storage directly attached to them. And there's actually a lot of benefit here by making these a physical proxy. The first of which is that all of the CPU associated with doing the backups is outside of your virtual infrastructure. So you actually can have a very high-performing backup that doesn't put any duress on your vSphere cluster. It does leverage the storage network entirely for the proxy process here. And you can have direct attached storage. You can have separate LUNs. You can have JBODs. You can have even NAS targets for where those backups go. And all of the work associated with the backups can actually be taken outside of your vSphere cluster, which will really help you kind of have a knob and a dial to kind of dial up how fast you want your backups to go. Now, I realize you might not want to have everything virtual or have any physical environments. So this is kind of taking that same design a different way and using virtual appliance hot add. So those same 200 VMs, I can scatter out some virtual proxies throughout that infrastructure, or ideally, potentially a different infrastructure for CPU and memory reasons. And I can actually write these backups, again, to any storage, maybe an iSCSI LUN, maybe a RDM, for example. That's an option here. I can actually give a VM, an RDM for these backups, and the Veeam proxy or repository server could format that and write his backups on there pretty easily. Or I could even use, again, a physical proxy or a physical repository, or even a mix. That might be important as well, especially if you have mixed NFS, Fibre Channel, and iSCSI possibly. So hopefully it's kind of like a varietal menu where you can like mix and match these components in here, but probably that's all good on-site, but how do I get that off-site? So this is where it kind of gets interesting. And the first of which is getting these backups off-site. I like to say that, you know, getting backups off-site is easy, but getting the bandwidth to do so is not. So what this design here has all kind of the same activity as any of the first 5 designs, but then I've implemented this new writer that will take backups off-site. Now, I talked to a lot of people who actually set up like Veeam replication jobs or even Veeam backup jobs that write off-site. And the real problem here is that they may actually extend their backup window by doing that. If they, in our process, we take the virtual machine snapshot, we start to move data, and then we remove that snapshot. But that move data spot, if it goes over a WAN, that may end up taking a lot longer and leaving that VMware snapshot open. This design will actually take that VMware snapshot locally on the presumably local network, and then from that Veeam restore point, we have a new technique called the backup copy job that will actually build that virtual machine and its associated restore points off-site to any of the rules that I specify. And the multicolored line transfer can actually implement that transfer with a built-in WAN acceleration technique. Now, this particular technique is actually very versatile in that you can do all of this without extending the backup window, and you can even leverage a cache that we set on both ends. The thought is with the cache that it's easier to come up with disk space for cache than it is to come up with more bandwidth. So this cache will get predictive on our restore points and any blocks that move through as we do our backups. Now, the only catch here is when you do this type of approach, when you're writing a lot of backups off-site, and if we're using our GFS retention, which is a new feature that'll keep weekly, monthly, annual, and quarterly backups, we really need to think about deduplication, because practically when those GFS rules come in, The only realistic target is a deduplication appliance or something like Windows Server 2012 dedupe. Now, this particular technique can also work in the same site. We just may not need to use, we might not need to use built-in WAN acceleration. We can actually just use the local network, CIFS, SMB, etc., to transfer that data. Now, you can take that same design and get really fancy and put that in a public compute cloud. If you have a public compute cloud that can give you like a Windows instance and also some block storage, and that could even include the vSphere hybrid service, you can actually write these backups off-site into a cloud or even a hosted environment very easily. Now, the magic here, it's exactly the same. The only catch is you have to make sure that the network is protected through like an Amazon virtual private network, or if it's a hoster, a colo. As long as you secure that network connection, this particular technique will actually really help. Now, the magic here, you might have noticed, these two designs are kind of different in that one of them has a lot more storage on the right and a lot less storage on the left. Now, if you look at that, you'll see I have a couple of different VBKs. That's the Veeam backup format. On number 6 here, the logic with this one is I can actually introduce what our product manager calls the ultimate VM backup storage architecture, which is a piece of storage. It has a couple of attributes. It's very fast. Maybe it's primary class of storage. Has a relatively low retention, maybe only a week, because chances are your most frequent restores are going to come from last night's backup or earlier today. There's a relatively very low retention, and then ideally it also means it has a relatively high cost. Now, that also helps us on the restores. If we give it primary class of storage, it will actually perform a lot better than if we go with, dare I say, cheap and deep restore or cheap and deep storage for these restores. The magic here is that we also have this option to put it off-site, and again, that would be ideally a deduplicated appliance, and in that sense, the speed I/O is never usually as fast as what we would put on primary. So what we've done here not only is increase the speed of the restore time, we've also increased the speed of the backups, and let me explain why. If we keep a relatively low amount of retention here on number 6 on the left, what happens here is there's a limited amount of traversal for us to implement our compression and dedupe. There's less potential like blocks. Therefore, our backup windows will also shrink just from our own processing overhead. Secondly, we will also have higher performance on writes and potential reads for block hashing and matching. And then after the backup's done, the VMware snapshot's removed, then this backup copy job logic will kick in and rebuild this particular VM and its associated restore point to the other site, optionally with the built-in WAN acceleration. Now, if I look at the option with the cloud, you'll see that I have more on site, because I think if I was going to do what I have a nickname for this architecture, but I call it the crawl space in the cloud. But if I was going to do this, I would probably want to keep a little bit more storage on-prem in terms of my VMware backups. I might want to put it on primary. I might want to split it up. All kinds of different flexibility can come in with that. Now, all of that being said, there still is no real, guaranteed way to say, well, this is exactly how you do it without assessing how these virtual machines interact. Everything from their change rate to the size of the VMs, much less the protection requirements. All of those can really be dialed up depending on the source storage, depending on the amount of storage, depending on the backup windows, etc. But if there's any one tip to remember, it's to make sure that every one of the components, like the proxy, the repository, etc., just to make sure that all of them have the right amount of resources that's documented in the release notes to make sure that they can meet their performance expectations. And so with that, I do encourage everyone, if you have any question, to come over to the Veeam booth. We have this on display. I'm showing the version 7 stuff. You can see how these pieces and parts work. Doug and Anton are going to give a session at 4 o'clock over in West. And you can find more about us at veeam.com. I pretty much recognize everybody here, so you've heard of us at some level. But if you got any questions, I'll be around here to talk for a moment. And thank you, everyone, for sticking around for a bit. Cheers. All right, thanks, boss.